Me?
Yes, ma'am.
Okay, thank
Yes,
you.
ma'am.
Thank you. Good evening, everyone, once again. So let's begin the class. Yesterday we have created our cluster, right? And we were able to connect from our Jenkins server. So now we have to deploy some YAML file, right? Like to deploy some deployment object and service object, right? So let's write some YAML file. You may create a separate directory and put your YAML file here, or else I'm just directly creating a YAML file for Kubernetes, which is Java, Maven, deploy, and also service. Okay, I'm just going to put service object and deployment object in the same YAML file. Okay, now let's put the YAML file which will create a deployment object and service object. Say I'm not going to write this from the scratch because we know how to write this. Yeah. I'm just placing the content here. See, deployment object. We have learned this. Apps v1 deployment object and some name for your deployment and labels. And I'm not going to hard code it. Rather, I'll pass those as a variables. Okay, so app name, how many replicas of address book application. Okay, and my registry key. And I'm going to use some private image with a bill number. Where is this bill number coming from? See, if you see here, we are going to pull the code, compile the code, test the code, okay, and then package the code and create a Docker image. For each run, a Docker image will be created with a particular bill number. And I want to run that particular image. So I want to pass this bill number as a parameter to the YAML file. Because it's not any random image from Hub. I just want to run that particular Docker image which is created in the previous stage. And image pull policy, I have shown you how to pull the images from registry. We have to create this secret key on the cluster so that it can pull. And then service object, again service object is going to have some application name. And then this time the service is load balancer. That's all. This is for deploying your address book application on a cluster. Just go through this and let me know. Is this file clear for everyone? Because we already learned it. So I'll wait for a minute or 2 minutes. Go through line by line. Let me know if this file is clear or not. Go through it. I'll wait. Any questions at any point in this file, let me know. I'll wait.
Ma'am,
Hmm.
is the host name written in service file?
Which one?
Host name in service file?
Host name of which one? This is your service file. Host name of what? Which host name?
We are using load balancer, right?
Hmm. No. Load balancer, whenever you create a service of type load balancer, it will create a physical load balancer at the backend and it will create a DNS. It will create a DNS. This file will create a load balancer service which will create a DNS. Then you get the host name. Then you get the DNS.
Yes, ma'am, got it.
Once you create it, if you check with kubectl get svc, then you can see the service and the host name where you can access your application. I'll show you what happens at the backend. When you run this, what happens is on your EC2 instance, here you can see something called load balancers. Okay, whenever you create this load balancer service using cloud providers like EKS and all, it will create an external load balancer, a physical load balancer at the back end. Okay, it will create here, which is costly. Means this cloud providers will create a native load balancer, which will have a DNS. Do you see here DNS? We can use that to access the application. Go through every line. App name, bill number, got it all of you. 10 participants joined as of now. Until I get confirmation from each of you, I'll just wait here. So please confirm if it is clear. You can message me or say yes or any questions. Thank you, Tanmay. What about others? Be quick, please. Thank you, Chakrapani. Go through it and let me know. I'll wait. Thank you, Prakash, for confirming. How about other people? Thank you, Uday.
Hello, ma'am.
Tell me.
Ma'am, this app name, we will take it from the Jenkins files.
Yeah, from Jenkins file. From Jenkins file, whenever we are calling this, we have to pass from Jenkins file.
Oh,
App name and bill number will be passed from Jenkins file. From Jenkins file, we'll be calling this file. Good to go, everyone.
Yes, ma'am.
Okay. Now here this is ready. Now from here I'm going to call this file. Okay. From here I would like to pass the environment variables like name of the application and so on. Okay. So here I would like to pass the app name. So I would like to create an environment variable for it. Okay. We can create our own environment variables and use them throughout. So environment variables will be defined with environment block and the variable name is going to be app name. Okay, I would like to pass here, let's say Java Maven app. Okay, that's going to be the environment name which I'll pass. And anyway, build number we have. Every run a new build will be, new image will be created. All of them will be stored on that particular image I would like to run this. Okay, so now let's call this file. How do you call this file? sh. Okay, call the file which is Java Maven deploy dot svc. Right, actually we should be calling it. Let me delete it. First, we should call a kubectl command, right? And kubectl, yesterday I have shown you. Call it from the location. It was under usr local bin kubectl and apply -f. Actually, the file name is java maven deploy service.yaml. Agree with this command, all of you? Okay, so this is how you can call the file. But to this file, I have to pass some variables, right? Like environment variables, like app name is going to be this is the user defined environment variable, means I have created it. And this build number is system defined environment variable, Jenkins inbuilt environment variable, right? So if you want to substitute environment variables into this file, you have a tool or a utility called env subst. That's called environment substitute, environment variable substitute. To which file? Put the file name. Is the file name correct? So env subs, pass the variables into this value and give that as an input to this command. Here you need not write the file now because we were passing it just hyphen. That's all. So what happens now? Environment variables, whichever there in this Jenkins file, will be passed into this file and that is given as input to kubectl apply command. That's all that will do. That will take care of deploying or running the YAML file. That's all. Got it clear, everyone? Let us save this. Git commit -a -m added deploy stage. Okay, all the changes were added and committed. And first of all, this is not at all staged. Git add dot. Now git commit added YAML file for Kubernetes. Okay, that's all. Let us check the status. Your branch is ahead by 3 commits, nothing to commit working. Okay, now let's push to remote. Git push origin. What is the branch name? Yes. Okay, now let's go to our Jenkins server, right? First of all, let's check our cluster. Unexpected rollback. AKS node group on request T2.micro is not supported in the availability zone. No way, I have to create it again actually. T2.micro instances. The region is not available. I have started this some 40 minutes back, but still. Okay, meanwhile, what shall we do? Once you deploy it, actually cluster should be there to do that. Actually, the idea is once the cluster is ready, we should run the YAML file there, deploy our application and scale it. Scale it means when the resources are not enough, your pods will fail. So we'll deploy a autoscaler. Autoscaler should be configured manually. So those are the steps we need to go through. But unfortunately, cluster is not that ready. Anyway, we have here kubectl, right? But we have to change the config file once again as per the cluster details. Yesterday we have discussed this, right? Cube. Again, you have config. We need to modify this a little bit. Okay, we'll do that. Before that, any more questions? Meanwhile, the cluster begins. Have anyone started your cluster? Have anyone done this cluster setup? Okay, cluster not yet set. If cluster is ready, just try to run the YAML file. You can deploy the YAML file. I have just pushed to GitHub. You have the YAML file on GitHub now. You can deploy it if it is ready. Meanwhile, let me delete all the resources available in the old region, like this is Mumbai, this is Tukano. It says it was ready, yeah?
Hello, ma'am.
Yes, yes.
Ma'am, how will this Jenkins server communicate with EKS cluster? We haven't passed the credentials to the Jenkins file.
Yesterday we did, right? Not Jenkins file. See, this Jenkins server is there, right? Like this particular November 24th, this is the one. On this server, we have created cube directory, we have placed config file, isn't it? This config
Mhm.
file is having the information of the cluster endpoint, cluster certificate authority, and then we can run kubectl commands from this. Means it could connect to the cluster. See, after connecting to the cluster from here, we are creating this YAML file. Connection is already done from the server manually, from the command line. Once it is connected, we are running the YAML file from the Jenkins file. Understood?
Okay.
Connection,
But then we will do this on every server, right?
not on every server. See, we need to connect to the cluster. From which server? From which server? From Jenkins server. Means, see, this is your cluster. Okay, this is your EKS cluster, cluster demo cluster, but this is your cluster. Okay, you want to connect to this from your Jenkins server. So on that Jenkins server, kubeconfig file should be present. This kubeconfig file. So on that Jenkins server, I place this kubeconfig file. You need not connect to this cluster from all the instances, isn't it?
Oh, yes.
I want to run kubectl apply command from one particular server. From a server, I want to deploy onto the cluster. This server could be anything. It could be a Jenkins server or it could be something else, whatever it is. On that server, kubeconfig file should be present. So I have placed kubeconfig file on that server. As of now, I am running kubectl commands from my Jenkins server. So I have placed this kubeconfig file on my Jenkins server. Got the point?
Yes, ma'am.
And by the way, it was saying error, but here cluster is there. Let me check once. See, cluster is there. Yeah, it was active. Just let me check once. Give me a second. Um, I'll do one thing. I'll check from the UI. Hmm. I'm just checking whether it was the new one. Okay, my APKs cluster. No. See, cluster is not yet completely created. Okay, so let it finish. Nodes were not there. This is a new cluster. Yeah, any more questions about the connection, how you are connecting, what you are connecting? Any more questions? Understood. See, you could be running this actually here in the Jenkins file. I'm running this stage, right? I didn't write agent anything, just default means it runs on the Jenkins master. Means your Jenkins master should be available to connect to the cluster. That's why I have added kubeconfig file. Suppose if you are running this on a remote machine, on that remote machine you should have kubeconfig and it should be able to connect to the cluster. Making sense? First, from whatever server you are running this, that server should have kubeconfig file like this, and so that it can connect to the cluster. Understood, all of you? Oregon region, just let me delete all the old resources, if anything else there. Clear it up. Actually, you can delete. The best method is to use EKSCTL delete command to delete all of your cluster resources. But in case if you miss doing it or else later on you have to delete, just delete from the UI as well. Just don't keep all of those. Cloud formation. And right now we are creating the cluster in not in the Oregon region. We are creating in US West one, which is California. Hopefully it should be successfully created. It has created, but the nodes should be ready. So to dashboard. Instances were not yet ready. I have to wait. So this is my Jenkins server. Okay, this is the Jenkins server from where I'm connecting to the cluster. Okay. Still about to create. Let it finish. Okay, meanwhile, we'll do one thing. Let us create a job here, or else I think I have already a job here. Meanwhile, let me set this up. Give your cluster details, give your GitHub credentials, GitHub URL. Okay, this is the one. And which branch we are placing the code in? It's a Java Maven app CAC. Okay, right. This is all set. Yeah, once our cluster is ready, we shall run that. No instances set. Okay, it's cluster. Here also we should change this config file with the new cluster information once it is ready. Yesterday we did this, but because it's a new cluster today, we have to do this. So once it is connected from the Jenkins file, we shall deploy the YAML file. So let's wait for a couple of minutes. One more thing we need to do. Meanwhile, let's do that. Another thing is, see, we are going to create a cluster on this, right? We have to use those credentials, meaning go to your Jenkins. Okay. Credential store. AWS access key, secret key should be available here. Just come to credentials, manage credentials. Okay. Create a new credentials. Global credentials, add credentials for access key and secret key. So the kind of the credential is secret text. Okay, secret text means I'm just going to place the access key and secret key. So here actually you should place the access key and put the credentials here like Jenkins, AWS, access, give something, access key, ID, put the credentials here. Like I have shown you, right? Yesterday you have to download that and use them always. So I'll just place those credentials. Okay, done. Similarly, another one for secret key. Username with password. No, it's a secret text. Put the secret access key. Okay, and give some name, something like Jenkins, AWS, secret key. Right? So that will do. And we have to use them in our script. We shall use them once it prompts for. Until then, I'm not going to add it. Once it prompts, we shall add it back. Secret key. Secret access key. Any name you may give. So, access key ID and secret access key. So, done. So, these credentials will be used to connect to the cluster, connect to the AWS account first. Okay. So, let's see. Okay, it's about to create this time, I believe. Hopefully. Yes. And check for the instances. EC2 instance. Mhm. Waiting for cloud formation stack to create them. And US West 1 is the region. US West 1. And if you go to the cluster, if you see the workloads are not yet ready. Okay. Kube proxy, these were ready configurations. Workload overview, instances were not yet ready. Haven't I given any instances? Node group, node type, T2.micro, nodes 2, minimum 1, maximum 3. Nodes are not yet ready. Attached nodes. Let's wait. See, whenever you are doing the CKS hands-on, plan to do the hands-on in an hour or two. Like you can just create your cluster and start hands-on all at once and then delete the cluster in one go. That will do. Okay, rather than just creating multiple times, keeping that on hold, try to finish the complete hands-on in one go. Because on EKS, the hands-on is very less. We just create a cluster, deploy this YAML file and auto-scale it. That's all. Rest of all concepts we have already learned in the cluster with the cube atom setup, isn't it? So you can just do it all in one go. Okay, now they were getting ready. Instances were almost ready. Okay, 2 instances, 2 node cluster. So EC2. Okay, now the cluster is almost getting ready. Okay, demo cluster 1 and okay, configuration almost done. Now, shall we update this? Meanwhile, this completes. Okay, it is fine. It's created. Yeah, it's ready. Now, kubectl get nodes. Obviously, from here I have created the cluster. It should be available. You can see the nodes here. Okay, also config file might have been created. Go to kube directory dot kube. Okay, it will have config file which will have all the cluster information. Okay, this data should be updated here as well. This is my Jenkins server. Okay, on this Jenkins server. Okay, as a root user, here go to kube directory config. Here, 3 things we need to do. What are those things? Server endpoint. You may copy this from the console or else you can copy from the original config file also. Where is the cluster endpoint? Server endpoint. Okay, this is the server endpoint. 1 minute. Actually, here is one thing shown and here is the other one. Okay, yesterday we have created one, right? So just make sure you are copying it correctly. Okay, this is the one. This is the server endpoint. Let me cross check with that on the UI also. Server endpoint. Okay, it was same. Just copy this. Come to our cluster, place the server endpoint. And then this one, the certificate authority. Replace this certificate authority as well. This is the old one, or else we can create a new file. Let me do one thing. Let's create a new file. Delete this. Okay, create a new config file. New config file. And the data here, what is the data we need to place here? We have that in the official documentation of kube config file. See here, you have a documentation for kube config file. Just copy it from here. Rather than modifying the existing one, just copy from here. Okay. Now here replace the values like the server endpoint. Okay, just come here and the server endpoint. Certificate authority. Replace all of them properly. Go to the UI, get the server endpoint, place it here. And then the certificate authority as well. Certificate authority. This is the one. Okay, and then the cluster name here. Okay, just place it here in the double quotes. What is the cluster name? Demo cluster 1. Right, that's all. Now let us save this. Now let's check kubectl get notes. Right, perfect. It was working fine. Yesterday we have checked from a job in Jenkins also, right? So it was all doing good. Now let us run this job. All set, right? Anything else missing? So let us run this job. Okay, any corrections required? We shall modify them. Build the job, like run the job. So our interest is the last one, additional new stage should be added, right? Let's monitor from here the console output. MVN compiling stage, test stage. Okay, something gone wrong here. Need to be a root user to perform this. Okay, let's check the YAML file. Mm, yeah. See here, we have added steps for installing Docker and starting Docker on the machine before we run that, right? So that should be a root user. So let's make the changes, commit them. That's what like you keep on modify with the corrections and run that finally. So let's run this once again. Let's run the job. One more failure will be there definitely. See, now it is working fine. If the Docker is not there on the Jenkins server, it was installing because Docker is there. It said nothing to do. Docker is installed. Build the image, push the image to hub. Hub, what is the image? It should be pushed with the tag name 11, right? A image with the tag name 11 should be pushed to the hub. So Maven, Java Maven repositories, tag 11 should be pushed to there. 11, yeah. 12 maybe someone else some time back it was there. Now the new one 11 should be pushed. See, it has logged into private repository and now it was pushing. Do you see that? So because I have given build number as a suffix to the image name, it was pushing this. Okay, see here now kubectl command were executing, right? And it says finish successfully. Okay, it went successfully because already the login is there on this machine. What I mean to say is it might have failed because here we have used this registry, right? It's a private registry. It went fine because already on this machine, on this Jenkins server, Docker login is there, right? So it went successfully. Otherwise, create the key. I have shown you creating a key yesterday, right? So you have to create the key so that it can log in. That's the only step you have to do. Okay, and now, yeah, it says it was like just go to the job. And also on the hub image should be pushed, which is 11. Let's see. Yes, do you see that? It was pushed a minute ago. And that particular image was executed in the cluster. Meaning port forwarding should have happened, or else just check the cluster. Anyway, kubectl get pod minus o white output white. Okay, see one, but it failed. See, actually command is executed. Yeah, see it failed. Image pullback failed. Whenever it failed, this is how you can check the errors. Kubectl describe pods. Okay, or else this pod name, this is a pod name, right? Describe pods. See here, DevOps trainer, MVN private repo. See the image name is incorrect. Just go to this. See, it's a private repos. Okay, that's a correction. Okay, repository name itself I have given incorrectly. See here. Repository name is private repos. Okay. Now again, push the changes. Push. And now um, run the job. Meanwhile, 12 image is already there. Let me delete it. Now let us run the job and see what happens. See image 12. This is a 12th run. So build number 12. Okay, now it was executing. Let's see. Get pods. Still error. Let's see what is the error. Error pulling the image. Obsidian. Describe pods. Successfully assigned. Pulling image. Failed to pull this image. Full access denied. Okay, but still means you have to provide the credentials. Even though Docker login is happened here. Here, from where is this image getting populated? Means if you see here, image secret. Here there is a my registry key secret, but is the secret available on the cluster? Okay, see actually Docker login should be done on the cluster, not on this Jenkins server. Are you getting me? I said it will work because Docker login is done, but that's not correct. Docker login should be done on the cluster, not on this Jenkins server. Am I correct? Yeah, got the point. So because it was using some a secret here called my registry key, but that registry key is not there on the cluster. It could not pull the image obviously. Okay, so let's create the cluster with that name. How do you create it? Yesterday I have shown you. This is another way to create secret Docker registry. Okay, and the key name you have given there is Docker registry key. Okay, and then Docker server means Docker registry address, that's equal to docker.io, and then Docker username is Devops trainer, and then Docker password. Okay, you have to put the password here. Let me put the password here. Um, okay, just give the password, and now if you check kubectl get secret. Okay, so the key is ready. This is the key it was using, right? My registry key. Okay, now let us run this. Yeah, let's run this now again. Get pods. Okay, earlier ones are terminating. Now the new pod is running. Do you see that? Working fine. And it was for one more thing. Important thing is let's check our service. Load balancer service this time, right? So get service. New service will be created and the type is load balancer and this is the DNS I'm talking about. Also on your Jenkins console, here if you go to load balancers, see, you should not check load balancers in the Mumbai region, isn't it? Where is your cluster? Your cluster is in US West 1. So here you should go to your EC2 dashboard. Here your load balancer will be created, right? Load balancer which will be forwarding the traffic to these instances. So go to load balancers. Okay, this is your load balancer. And here you can see it was added to two instances. It was working as a load balancer for two instances and this is your DNS. Right? Copy this DNS. Hit this DNS on which port? And it is showing that way because it's an address book WAR file. So the endpoint should be address book. Got it finally? Your application is deployed on the Kubernetes cluster. That too through the Jenkins pipeline. That too not just from the UI, through the pipeline as a code concept Jenkins file. Isn't it great? This is how it works in reality and this is the advanced concept of the complete course. This is the final deployment onto your cluster through automation. Complete automation via script, not just from the UI. Interesting, isn't it? Yep. See, finally deployed to EKS cluster. Yep. So put some effort. Okay, definitely it will be a bit complex for you, maybe for when you're doing for the first time. Okay, but definitely try doing it. Okay, this is how we do in the projects. Okay. And now, yeah, it is perfect. Now I am having two nodes on my cluster. Let me show you much more interesting things now. Let's go here. I am having two nodes now. Okay, now fine. But what I want is, I would like to scale this address book application. Okay, I'm directly modifying it. Meaning, I'll just make modifications on GitHub. Where is this GitHub? Okay. GitHub. Okay, this is the branch. Yeah. See, till now I'm just having one replica. Okay, let's suppose I just want to run 10 replicas. What happens? Anyone? I made a commit, so I'll run the pipeline. Can anyone tell me what happens now? Meanwhile, I'll just back up these files. Yes? What happens now? What should happen now? Yes? Anyone? Okay, repeat the question. Okay. What I did is I have scaled my pods to 10 pods. Okay, I have scaled it to 10 pods and I'm running that application. I'm running the pipeline. So what happens now? Can it run 10 pods? What happens to the pods? What happens to the cluster? See here, only one is available. It tried to scale, but all of them are in pending state. Yeah? Why they are all in pending state? Will they be created ever? If I wait, will they be created? If you want to know what is happening, describe pods. Okay, describe the pods. When you describe the pods, you can see here the information of all the 10 pods, and what it says here is, okay, let's wait. See, too many pods and failed scheduling. Default scheduler, we have learned the concept, right? Your scheduler will schedule the pods. Depending on the resource availability, your scheduler will schedule the pods. But here it says clearly that too many pods to deploy. Means there are no enough resources. 0 out of 2 nodes are available. No node is available to schedule. Means there were not enough resources available. So obviously they'll fail. Your deployment will fail. Okay, they just get hanged up. So what you have to do? Yeah, you have to add the new nodes to your cluster, isn't it? Because I just have only 2 nodes, there might not be enough resources for these 2 nodes. So I have to scale them. We have given, if you remember, we have given minimum number and maximum number. That's just a range. It cannot automatically scale up. So you have to enable this auto scaling. How do you do this auto scaling? Let's talk about this. You have to deploy auto scaler. Okay, to do this, 1 minute. Let me deploy the complete, let me delete it. kubectl delete deploy. The name is get deploy. I'm first deleting it and I'll recreate them later. Only 2 are ready, 2 are available. So just deleting it. kubectl delete deploy. I will start it. First, let us configure autoscaler. How do you configure autoscaler again? Configuring autoscaler is not automatic. Okay, you have to configure. And there is again a complete documentation on deploying autoscaler. Everything is dependent on documentation here. Why? Because this changes. The commands may change, the cluster configurations may change. Always you should be habituated to refer this and do it. Because today I use some command, today some policies may change, some AWS configurations may change, so it may not work. So first follow this. It says to create a policy and role. But before that, it says to deploy the cluster autoscaler. How do you do that? Again, your cluster autoscaler runs inside a pod. So this is the official documentation, cluster autoscaler discover.yaml. Okay, you have to apply this. Means you have to download this YAML and run this file. kubectl apply -f cluster autoscaler. Run the YAML. Download the YAML file, run the YAML file. Your cluster autoscaler will be created as a pod. Okay, you can check them under kubectl get pods, but it is not available in the default namespace. Rather, they were all by default available in kube system namespace. Okay, see here. It was still in pending state. It should be available in a few minutes. Sometimes what happens? It may not be available because of the nodes you have. Here we are using t2.micro instances, right? This cluster autoscaler is huge, which may not be enough to deploy on this t2.micro. So you have to have some huge instances for it. Let's make sure to delete everything else. kubectl get deploy. Do we have anything? Get stateful sets. We don't have anything. Actually, the cluster autoscaler we are seeing here, right? It should be available. Okay, it should be running. so that your cluster autoscaler will work. But before that, maybe let it give some time before it starts. Okay, now what else you have to do? You have to make some configuration, some small changes by editing this deployment. I'm just showing the command. See here, edit the deployment. Like you deploy, like you edit any service, you can deploy this, you can edit the deployment and set this parameters save to evict to false. Means it should not remove its own pods when auto scaling. So make this false. That's the one thing you need to do. And the other thing is, let's go and edit that. You may also edit this way. Just go here to edit the file. See, this is the option we have made to false just now. Similarly, here are the few changes you need to make. What are the changes? Just scroll down. The first change here is evict to false, and the second one is, if you scroll down here, here you are seeing something like cluster name, right? So put the cluster name, your own cluster name. It's a demo cluster 1. Okay, that's the second thing. And the third thing, see, it's coming from a Docker image. Okay, your pods, like I said, autoscaler is coming from a Docker image, which is from GCR, means Google Container Registry. Okay, this official image you can use. And one more thing is, this Docker image version should be same as your cluster version. We are using cluster version 19, so just put the same, and that's all. That's all you have to do. Okay, let us save this. And now if you see, okay, it was still in the pending state. What you can do is, whenever you're creating cluster, make sure to create the cluster with a big instance size, means like T3.medium or a T2.medium will do, so that your pods can be accommodated. Here, no enough space. How do you know that? Just check it out. kubectl describe pods and this particular pod, or else describe the deployment. Okay, what I'll do is kubectl get deployment. The deployment name is, okay, first let me get the deployment in the kube system namespace. Okay, this is the deployment. Okay, you can check this. You can modify this. kubectl -n, the kube system is the default namespace. Describe deployment, and the deployment name is cluster autoscaler. Okay. Cube. Okay, and it says that if you just see here, you may get some information of what is happening, because it says it was still in pending state, isn't it? So let's check it out. It seems all good here. Cluster autoscaler, the image from which it was coming, the changes we made, and then the node group autoscaler. See, this is the size of your pod, okay, whichever it was running, but that may not be enough for these pods to run. Okay, one replica is created, it was saying scaled up, scaling replica set. Let us also check the pods. kubectl -n describe the pods. Few pods are pending, right? And the pod is cluster autoscaler pod. Yeah, see here. Okay, it was showing information of all the pods. The pods which failed are cluster autoscaler pods, right? Just scroll up. These are kube proxy pods, and then Here, fail to create pod, RPC error, unknown description, fail to create sandbox, fail to set up this pod. Also, just scroll now. Yeah. Okay, no nodes available to schedule the pod. 0 by 1 nodes are available. One node has taint. Means master is in taint, right, already. So the other node is also like it cannot hold the pods and your pods fail here. Got it now? So no enough resources. Means, see, for first of all to deploy your cluster autoscaler itself, your cluster should be of a good size. Means here we have created a cluster of size T2 dot medium instances. They were all T2 dot micro, right? We might have created T2 dot medium. So if I create again, it will take some time. You just create a cluster with T2 dot medium instances. Okay. And once you deploy, what happens? Whenever you are running this YAML file, means like if you are scaling this pods to 10 and all, new nodes will be added up here automatically. Here new nodes will be coming up. It would be really interesting to show you, but by mistake I have created T2.micro. I missed this step. We should be creating a huge cluster. Okay, will you try doing it? Everything is same. Deploy the cluster. Here you should see when you create with the T2.medium, you should see here kubectl get pods in this default namespace cube system. Okay, whenever you do this, here your pods should not be, particularly this cluster autoscaler pods should not be pending. They should be in the running state. Then once you increase the number of pods, your number of nodes will be increased automatically. Right? So try doing it, but do this very carefully because it is charged. It's not for free. So if you just put too many instances, means if you run 40 pods and if your cluster is scaled up to some 40 number, 4 number of nodes and all, you are going to be charged. So take care of do this a bit carefully. Will you try doing it? And also here one more thing is there. Key pairs, load balancers, auto scaling groups. See, we were creating instances, right? By default, they were into auto scaling groups, meaning we have set some range, isn't it? See here, 2 instances we have set. If you want, you can just modify here also. You can change those ranges here. Like I have said, 2 is the desired capacity, then 1 minimum and 3 maximum, right? You can change here to be desired state like this. You can change it. And here I have chosen T2.micro instances. You can change. The next coming up instances could be T2.medium and all. Okay, here you may change them. Like T2.medium, which offers 2 virtual CPU and 4 gigs of memory. But be careful, you'll be charged for this. Okay, just make your cluster, create them a bit huge instances so that it should be doing good. See here, T2.medium, because I said 3 medium instances, 3 desired capacity, right? It was creating a new node. But instead of you going and modifying it, when you deploy this cluster autoscaler carefully, it should be working fine. Let me check if these pods may be successful. I should deploy it once again. Let the instance start. Okay, it was running. Let me run the pods. This T2.medium should be accommodating. kubectl get pods -n cube system. Let me apply this once again. You have to delete this entire thing and do this. Okay, delete this deployment and do this. I'll try once again. Just give me a minute. kubectl get pods. Yeah, do you see here? I thought of deleting it, but because I have added T2.medium node, do you see that? Okay, your cluster autoscaler pod is running fine. Yeah. Now let us check our pods. We don't have our pods actually. Let's start it. Yeah, sorry. Understood what happened? kubectl get pods. Okay, no pods. I'll run the YAML file now. kubectl get deploy. Okay. kubectl get pods minus n cube system. Before that, I would like to check one more thing. We have to make sure the configurations were intact. Just let me put this. Okay, it was all set. Okay, it's okay. Now let us do. See here, one more thing you should do. See here, we are enabling our autoscaler, right? We have to create a policy so that our instances should be allowed for autoscaling. Just come here to the documentation, just for reference. See here. What should you do? Create an IAM policy and role. What is a role actually? If you want to give permissions to one EC2 service, okay, so that it can work, it can auto scale these EC2 instances, you should create a policy and a role. Attach the role to a service. This is what you need to do. So first create a policy. Here is the JSON which you need to write. So just copy this. Now come and create a policy. Go to our EC2 instance. Go and search for IAM where you can see users, roles and policies. Create a policy. Create a policy. Here you have to put the policy is nothing but set of rules. Go to JSON. Here get the policy from the official documentation. This may be changing. Okay, better you copy from here. So it's giving permissions for auto scaling groups if you see. So just put this policy here. Okay, now create the policy. Give some name to the policy. Let's say some EKS policy. New EKS policy. Just give some name. Policy is nothing but set of rules. Okay, just add this. And here we should do one more thing. Okay, create the policy. Yeah, this is the one, new EKS policy. So once this policy is created, attach this policy. How do you attach the policy? Go to roles, search for our cluster role. Our cluster will have a role. Just search for the role. Our cluster name is demo cluster one, right? Service role for support, service role for build service. Let us search with EKS. Okay. Yeah, this is the one. EKS CTL demo cluster one. Okay. So attach the policy to this role. Not creating a role. Actually, we should attach this policy to the role. Policy is created. Demo cluster one service role. Okay, let's go there. Okay, here you have to attach the policy we have just created. New policy. Okay, this is the one. So attach the policy. Okay, go to the particular role we have and attach the policy. That's all you have to do. That's all. Now let us come back and let us run the YAML file. Means let us run this job. Also, if you see, we have 10 pods. Earlier they were all failed, right? Now let's see what happens. Okay, it says it was successful. Let's see. QCTL, get pod, output. Do you see that? They are all almost everything is running. And whichever the container creating state, it should be enabled. Like it will be started in few minutes. Right? All the 10 pods. Yes. Means what happened to your nodes? kubectl get nodes. See, all the 3 nodes were enough because one is t2.medium, huge instance, right? Let me do one thing. I'll do one thing. Just go here. Instances. Oh, not Mumbai. EC2. Okay, let me do one thing. I'm just deleting this t2.micro. Also, we can see how many are running on which node. Okay, I'll just delete one node and see what happens here. Uh, the IP address of this particular node is 1, right? Sorry, these are the ones. All of them, do you see that all of them are on T3.medium, T2.medium instance, I believe. This is the one. Because resources are enough. Enough resources are there, they were all running here. No, this is not this one here. Demo cluster node group. This is the public DNS. Where is the private DNS? Yeah. See, all of them were here. Okay. So if you remove this again, or else if you increase the pods further, number of nodes could be increased. Shall we increase them further? Let's say 40 pods. It may take some time. So that's all about the cluster auto scaling. Do it very carefully and don't just put 40-50 pods like this, because so many instances should be created which takes some time, and also which takes some time, and also which may incur you some cost. So take care of this. This is some advanced concept. If you prefer to just understand this and leave it, that's fine. You need not do hands-on on all this. Like I said, so many limitations, so many constraints are there. If you have some understanding, this is how auto scaling can be achieved. That's enough. So that is all about Kubernetes. Any questions? Hope you got good understanding on cluster auto scaling, deploying via pipeline. Any questions in this part? Understood, everyone? Any questions?
Ma'am, is there anything extra we should learn?
Hmm? Anything?
Hello?
Anything?
Is
Yeah.
there anything extra we should learn? Extra from Kubernetes we should learn by ourselves?
Nothing else required. This is enough. See, in anything extra, in sense, these are used mostly in the projects. Anything here and there, if any project is using some other resources, something else, there might be there. But you cannot guess them and learn it. Okay, no project uses or works the same. So as much as you learn,
Yeah,
there
okay.
might be something else they might be using. So you need not learn anything else except with the content you learn. Definitely, you can through your interviews you can get started with your projects. Here and there, if anything comes up with the knowledge you have, you can refer the documentation and use it. You need not learn something else beforehand.
Yeah, okay, got it. Thank
All right, then we'll close here and we'll continue tomorrow. Tomorrow we shall be starting with the Terraform. Go with the hands-on, but be careful when you are doing this hands-on, or else listen and just do hands-on till yesterday cube Adam. That is also fine. All right, then. Bye, everyone. See you all tomorrow.
Ma'am,
Mm.
ma'am, you are telling only this class not to do the hands-on, ma'am.
I'm not saying not to do. I'm saying you can keep it aside. You can ignore. EKS, complete EKS.
Okay, like yesterday's class and today's, ma'am.
But
AKS
the
is
concepts are same. Everything is same. Setup you do it differently, and because you do the setup through EKS, you can do auto scaling. You can see load balancer. You are deploying through the pipeline. Okay, but if you just listen, that will do. The concepts are same. Services, deployment objects, all of them remain same. If you just listen this much, means if you know what is happening, that is enough.
okay, okay, ma'am. Okay, ma'am. Thank you.
All right, then see you all tomorrow. Bye, everyone.
Bye, ma'am. Thank you.